Okay guys, so here we go, another set of questions to be practicing. So here's one on practicing your expansion skills and simplifying. Something to do with products of primes. Question on criticising a graph drawn to represent inequalities. Ratio question, again, keep practicing these ratios, you're going to get quite a few of these in your exams. And one to do with the standard exponential formula for growth and decay, where you've got to find out some missing values for P and Q, etc. Okay, so let's go back to the first one. Let's get through the answers. Okay. Alright, so we've got to expand and simplify. So we can see here we've got a double bracket, so we'll do that first. Lots of different ways of doing the double brackets. I just like doing the grid so I can see what's going on. So we've got 3x squared times 2x, 6x cubed. 2 times 2x is 4x. 3x squared times 5 is 15x squared. And then 5 times 2 is 10. And then this one, well, it's a straightforward multiply that by that, and multiply that by that. So we end up with 6x cubed. And then 6x times 3 is negative 18x. Okay, just remember x has got a power of 1, so when you're multiplying here, then the power of x must go up by 1. So x cubed. Bring all this together, and so we end up with 6x cubes plus 4x's plus 15x squared plus 10. And then from this one we ended up taking away, we've got to be really careful here, this is a take away this, so we're going to take away 6x cubes, and then we've got to take away this, so we've got to take away negative 18x, that becomes plus 18x. And then we bring all together like terms, so 6x cubed take away 6x cubed means they cancel each other out to 0. And then we've got 15x squared, so 15x squared. And then we've got 4x plus 18x, so 22x, and then we've got 10. Okay, so it's worth 4 marks, so we should do a check at the end. And if we put a simple value in, say 1, and then we can see whether we get the same answer with the original brackets and what we think our answer is going to be. So for our original brackets then, if we put 1 in, we end up with 3 plus 2. And then we end up with 2 plus 5, and then we're taking away 6, because 6 times 1 is 6. Lots of 1 take away 3. Okay, so we ended up with 5 times 7, take away 6 times, and 1 take away 3 is negative 2. So we ended up with 35, negative times negative is plus 12, so 47. So hopefully with this we get 47. So we've got 15 plus 22 plus 10, 32, 47. So our check worked. Okay, so worth doing the check just in case you make a silly error, particularly when you're dealing with takeaway involving negatives and missing the plus there. Okay, so that's that one. Alright, this question talks about n being a number, and it's been defined as a product of its prime factors, and it wants you to work out 3n squared. Okay, so basically it says give your answer in terms of y, so in other words we need the y there as well. So this is saying 3 lots of 2 times 3 to the power of 4 times y cubed all squared. Okay, so we go through, and this is power to a power rule. So if you remember, a power raised to another power must be the same as multiplying the powers. So we've got 2 to the power of 1, so that's 2 squared. And then we've got 3 to the power of 4 times that, so that's going to be 3 to the power of 8. And then we've got y cubed squared, so that's going to be y to the power of 6, and we've still got 3 of those. And we can see here that this 3 would multiply by this 3 to the power of 8. This 3 has a power of 1, so this will now make that power 9. So we end up with 2 squared times 3 to the power of 9 times y to the power of 6. Okay, so that's how that question would work. Recognising how the power to a power rule works, being the multiplication of 2 powers when it's the same base. and we recognise there's a 3 outside here because of the 3 being multiplied by n squared, and that means that power of 3 will go up by 1. And it says give your answer in terms of y, which we've done, and we want to work it out as a product of prime factors, and this is a product of prime factors, and we leave it in index form. So therefore we've done that, and we've done that. It's good to tick off each part of the question so you can make sure you've done everything. Okay, so that's that one. This question has given you an inequalities graph drawn, and it wants you to criticise it. It says make two criticisms of the graph. Okay, so basically we recognise that this is saying y is less than or equal to x plus 2. So they're saying that this is the line, so we just check it. So it does go through 2 as we'd expect the intercept point, and it does have a gradient of 1, across 1, at 1, across 1, at 1. So that seems okay. Y is greater than 3 take away x, that means it must cross at 3, and it must go, it's got a negative gradient of 1, so it must go across 1, down 1, across 1, down 1. Yep, that seems to be okay. It says greater than only, and so it must be dashed, so again must remember that dash line, so that's okay. This one was equal to, so that's why it's solid, so that's fine. And then this one says x has got to be less than 3, so we recognise that that will be a vertical line going through 3, and we can look at this line and we can see that it is going through 3, but it's being drawn as an equals line. It's saying it includes 3, and this does not include 3, so this should be a dashed line. So basically the first criticism would be this should be a dashed line. That is not equal to 3. Okay, so that's the first criticism. We can see that they've labelled the region R here, but then when we look at this, this is saying that y has to be less than or equal to x plus 2. So yes, it is less than x plus 2. It's saying that y must be greater than 3 take away x, that means we must be above the line. Well, here's the second mistake. We can see that R is in the wrong place, it should be here. Okay, so second criticism, region defined is here. Okay, so that's how that question could be answered. As I say, it was about make 2 criticisms of the graph, and we found the 2 criticisms. Okay, so we know that ratio in some form or other is going to be asked quite a bit in your exams. This is just one type of ratio question. We can see that they're telling us to work out A to C in its simplest form. So one approach would be to change this into fraction form, because we need to get A out of the way, because this wants to relate B to C, but I need the final answer to be A in terms of C. So I need to replace the B here with something to do with A. So basically we know that in fraction form the ratio is telling us that A to B must be the same as 9 to 4. And therefore, because I want to replace the B here with something to do with A, I need to rearrange this to make B the subject. So the B is going to come across here by timesing, the 4 is going to cross there by timesing, and the 9 is going to come across by dividing. So we end up saying that B is equal to 4A over 9. Okay, 4 comes across by timesing, the 9 comes across by dividing, and the B goes across by timesing. So we ended up with that. So then that means in here we can replace the B. So this is now saying we've got 10 lots of 4A over 9, and that's the same as 7 C's, and then we can multiply this out, so we end up with 40A's over 9 is equal to 7C. Because we want it as a ratio, then we know that we need to rearrange this to be A over C. So we'll have 40A over 9, but the C comes across as dividing, so it'll be C, and that will equal 7. And then of course we want to leave this with just A and C, so it means the 9 goes across by timesing, so we end up with 63, and the 40 comes across by dividing, so that's what we ended up doing there. So we ended up timesing by 9 and then dividing by 40, and here we divided by C. And now we've got to do it in fraction form. We know the relationship of A to C must be the same as 63 to 40. And we look at these two to see if there's any common factors apart from 1. We can see that neither of these have got common factors, so that's as simple as it will go, because the question wanted it in simplest form. Okay, so that's the way that question could be answered. There are other ways, but that seems a fairly straightforward approach. Rewrite the ratios as fraction equivalents, rearrange to get the b out of the way because we need it in terms of a, and then swap it all about until we get a over c, and then whatever that fraction is, that must be the ratio. We've checked whether it will simplify, and it doesn't because there's no common factors apart from 1. Okay, so last question for today, guys. So we've got a exponential relationship here of the classic form y equals pq to the power of x, representing a graph that does this, where that will be the value of p, and it's an exponential. Okay, so it's that kind of format. They've just given you the relationship as power x minus 1, and we've got to find out the values of p and q so that we can answer this question. So what does this tell me? Well, this tells me that when y is 10, p times q to the power of 1 take away 1. So 10 equals p times q to the power of 0. Well, we know that goes to 1, so we know now that p is worth 10. Okay, so that's what that told us. And then this one, it tells us that when y is 0.3125, it was because we did 10 times, because we replaced the p with its value, q to the power of 6 take away 1. So we have 0.3125 is equal to 10 times q to the power of 5, divide by 10, so we have 0.03125 is equal to q to the power of 5. Because we want to know what q is, we take what's called the fifth root. So we do the fifth root of this, so q is equal to the fifth root. Now you can use your calculators, but this is quite a standard one. So we know that q is equal to half. Okay, so that then tells us the relationship then that these variables are related by is y is equal to 10 times half to the power of x take away 1, because we replace the p and q with the values we now found. And now we can find the value of y by putting in x value of 3. So we end up with y is equal to 10 times a half to the power of 3 take away 1. So y equals 10 times half squared. So basically we end up doing 10 times a quarter, which is equal to 2.5. So our final answer is y equals 2.5. Okay guys, that's it for today, so hopefully you'll get the practice in. Keep going, not long to go now, and you'll get a couple of months to relax.